So now we're going to do a hypothesis test, and we are gonna use Pearson correlation to evaluate the correlation between two stocks at the closing price of two stocks, right? First, we're going to import the libraries that we're going to use. Then we're going to input the data that we need. First, the stocks. Let's use NVIDIA and Amazon. Okay. Let's set the start date to 2020 to 2023. Let's download the data. Okay, so now let's just select the adjust close column. Now let's drop the nays. Now let's do a Shapiro-Wilk test. This test will show us if the data can be considered a normal distribution. So let's run this for the data from the stock one, NVIDIA. We got a real high Shapiro test statistic here. It looks like, since it's really close to number one, it looks like it's a normal distribution. But that is not enough. We have to check the p-value. If the p-value is higher than the alpha value, which is set in 5%, if the p-value is higher, it will look like a normal distribution. As we can see here, the p-value is really low. You see? So it doesn't look like a normal distribution, right? Although the Shapiro-Wilk test was really close to 1, the p-value shows us that it's not. It doesn't look like a normal distribution. So let's apply the same thing to the second stock. We got the same results. The Shapiro-Wilk test shows a number quite close to 1, so it would look like it's a normal distribution, but the low p-value demonstrates for us that it doesn't look like a normal distribution. Let's plot the histograms for the stock number 1, and this doesn't look like a normal distribution. What about stock number 2? It also doesn't look like a normal distribution. So we will assume that both of those data from those stocks are not normally distributed. Now let's see the correlation. Let's run the correlation, the Pearson correlation here. Well, we got a positive correlation, which means that if one increases, the other one increases as well. But it's not a real high correlation. There is not a real high correlation between them, because it's just 0.5. If it would be around 0.8, if it was closer to number 1, we would assume that it would have a high correlation, but 0.5, I think it's a random correlation, right? So let's check the p-value. It's not a real significant correlation. Let's check the p-value. We also got a real low p-value here. So let's see if let's check the significance between those two data sets. So we got three alphas here, 10%, 5%, and 1%. For all of them, since the p-value is quite low and lower than all of the three of all the three alphas, we can say that they are statistically significant for all the three alphas. Okay, even though the correlation are not real high. And that's it, guys. That's the Pearson correlation test hypothesis.